Hello, hello. So hello everyone and very good morning. I hope the audio and video is clear. So we will start our session. So today in the session of RCC we will be revising the concepts of column and footing. Okay. Is audio video clear everyone? Please comment me. Okay, is audio video clear everyone? Good morning Vignesh. So we will start the session. So in today's session we will be covering the good questions of column and footing. Column and footing. Okay. For your JEE examination, pre-stress concrete is not so important. Okay. So this is the 7th lecture. Okay. This is the 7th lecture. Oh, and rest of the topic we have covered. Okay. Rest of the topic we have covered. Now in this lecture I will be covering footing and column. So please note down, if you want the PDF of this lecture, this is my Telegram channel. Scan this QR code. You will directly reach to my Telegram channel, or find ASM Live, or search ASM Live on Telegram. You will be able to find this Telegram channel and you will get the PDF file of this lecture on this Telegram channel. Okay. So this is the 7th lecture. All the 7 PDF will be available on this Telegram channel. Whenever you want, you can revise this annotated PDF. Okay. Let's just start with the session. Shall I start? Okay. We'll start the session. This is the first question. Please answer this. This is the first question. Answer this question everyone. Yes, very good. Look, in case of column, area of longitudinal reinforcement shall not be less than. So look very carefully. In this question will be, just a moment. So look, yes, very good. So you can see very carefully that the minimum reinforcement, longitudinal reinforcement shall not be less than minimum. So in case of column, two provisions are there: minimum reinforcement as well as maximum reinforcement. Understood everyone? So maximum reinforcement here is Maximum reinforcement here is very good, 6%, and minimum reinforcement is 0.8% of gross cross section area. Please remember this, 0.8% of, here also 6% of gross cross section area. Yes or no? So hence the correct answer will be 0.8%. 0.8% of the gross cross section. This much is the minimum area of steel reinforcement required in the column, and maximum to maximum is the 6%, because if you increase the area of the steel bar by this percentage, there will be lot of congestion in the cross section of the concrete. Now moving ahead, next question. Answer this question, everyone. Answer this, just a moment. Now what is the correct answer for this question? Calculate the pitch of lateral ties. Okay, the pitch of lateral ties for a column of 300 mm square. Okay, 300 mm square. So this is a square cross section of area 300 mm into 300 mm with 20 mm dia longitudinal bar. So the main bars are of 20 mm diameter, 20 mm diameter. Okay, and 8 mm lateral ties. So diameter of lateral ties are of 8 mm. Okay, as well as the cross section area of column is 300 mm into 300 mm. It is a square cross section column. So what is the max pitch of lateral ties? Okay, very good, Vignesh. This is the correct answer. So there are 3 codal provision which states that, okay, least lateral dimension 16 times of the smallest dimension or 300 mm. है ना? Understood, everyone? Least lateral dimension. So the pitch of the lateral ties are 300 mm. Least lateral dimension, so it is a square, least lateral dimension is 300 mm only, and 16 times of the dia of longitudinal bar. Okay, the minimum dia of longitudinal bar. So you can see very carefully, 16 into 20 is nothing but 320 mm, as well as least lateral dimension is 300 mm and 300 mm. So minimum of this will be the answer. Hence 300 mm will be the correct answer. Minimum of the 3 values are to be taken. Understood, everyone? Now moving ahead with the next question. Next question is, in the design of column, the diameter of longitudinal reinforcement bar. So this is a very good question. This is a very good question. Please put a star mark on this. Okay, in the design of column, answer the question, everyone. In case of column, what will be the correct answer? The diameter of longitudinal reinforcement shall not be less than 12. Okay, be less than 16 mm, be more than 20 mm, not less than 10 mm. So in the column, the minimum reinforcement, okay, the diameter of longitudinal should not be less than, very good, should not be less than. So the minimum diameter of the bar that is used in the column is 12 mm. This you need to remember. This is a very good, very important question. In column, the minimum reinforcement is 12 mm. Understood, everyone? Understood? Moving ahead, next question. So you must have analyzed in the last few lectures, we are just covering the codal provision, because in your PSC examination, in your state AE JE examination, only the codal provisions are very important. Okay, so you need to very focused on the codal provision, especially in steel and RCC. Now moving ahead. So spacing of longitudinal bar measured along the periphery of the column shall not exceed longitudinal bars, spacing of longitudinal bars, okay, measured along the periphery of the column shall not exceed. So this is a very good question. Let us suppose this is a circular column. Okay, so these are the main reinforcement and these are the stirrups. So along the periphery, this distance should not be more than, should not exceed 300 mm, should not be more than 300 mm. So this spacing along the periphery should not be more than 300 mm. Option C is the correct answer. Understood everyone? Yes, this is the correct answer. Shall I move ahead? Moving ahead. Answer this question. Answer this question. Effective length of the column whose one end is fixed and the other end is free is, effective length of column, let us suppose there is a RCC column whose one end is fixed and the other end is free. So this is the column. So you can see very carefully, if the length is L, effective length is nothing but the distance between the point of zero bending moment. Understood everyone? Point of zero bending moment. So here bending moment is 0, here bending moment is 0. So if you take the mirror image of this, here also the bending moment will be 0. Yes or no? Yes or no? So the correct answer will be L or L. So 2L. 2L is the length. Understood everyone? 2L is the length. So it is greater than this length. Okay, effective length is nothing but L effective. L effective means 2 times of the L. 2 times of the L. Whose one end is fixed and the other end is free is equal to overall length, less than overall length, okay, greater than overall length. Yes, very good. So the correct answer will be greater than overall length. Option C is the correct answer. Greater than overall length. Understood everyone? Now moving ahead with the next question. Answer this. Answer this question. This is also a very good question. You need to solve the question without calculator. Please remember, you need to solve the question without calculator. Okay. Now look very carefully. How do we solve the question? Now in the cross section of column, you can see in the cross section of column there are reinforcement as well as there is a stirrup. Okay. Now this cross section will take the load P is equals to load taken by the stress in the concrete into area of concrete plus stress in the steel into area of steel. Yes or no? So area of steel is given as 1000 mm square, area of concrete is 10,000 mm square, area stress in the concrete is given. So M is modular ratio. M is defined as the stress in the steel to the stress in the concrete, stress in the steel into stress in the concrete. This is a question of WSM. So how do you get the stress in the steel? Stress in the steel is the M times of the sigma SE. M is nothing but 20 into 5 is nothing but 100. Yes or no? 100 Newton per mm square. So you can see very carefully, stress in the concrete is nothing but 5 Newton per mm square into area of concrete is nothing but 10,000 plus area of stress in the steel is 100 into area of steel is nothing but 1000. Okay, to convert this into kilonewton, multiplied by 10 power minus 3. 10 power minus 3. So 1000 and 1000 is being deducted from each and every value. So 1000 value is cut it here. Also 1, 2, 3. So this is nothing but 50. This is nothing but 100. So your answer will be 150 kilonewton. 150 kilonewton. So what will be the correct answer? Option C is the correct answer. Option C is the correct answer. This is a very simple question. Without calculator, we will be able to manage to solve this question. Yes or no? Understood everyone? Shall I move ahead? Okay, moving ahead with the next question. Answer this question. What will be the correct answer? This is a very simple question. You can see the load carrying capacity of circular column with helical reinforcement. Okay, let us suppose this is a circular column. Okay, these are the reinforcement. Helical reinforcement. Helical reinforcement means this. This is the helical reinforcement, and whenever you see the top view, so top view will look like this. Top view will look like this. Yes or no? So this is how you need to analyze the question. So whenever there is a helical reinforcement, load carrying capacity increases by 5%. Load carrying capacity increases by 5%. Yes or no? Yes or no? 5% more. Yes, very good. Moving ahead. Solve this question. An axially loaded column is of 450 into 450 mm size. The effective length of the column is, so the dimension is nothing but B is and D is equal to 450 mm, as well as the effective length of column is L effective. The effective length of column is 5 meter. Effective length of column is 5 meter. What is the minimum eccentricity of the axially loaded column? So E minimum eccentricity of the axially loaded column. This question already we have covered in one of the chapter. Minimum eccentricities need to be calculated. How do you calculate? Okay, minimum eccentricity is nothing but what the maximum value of L by 500 plus D by 30 or 20 mm. L by 500 plus D upon 30 or 20 mm, whichever is maximum. So the length is, effective length is 5 meter. 5 meter means 5000 mm. 5000 mm divided by 500 plus depth is nothing but 450 divided by 30. Okay, comma 20 mm. So whichever is value is maximum. So this value is nothing but 50 and this value is nothing but 15. So 65 comma 20. 65 comma 20. So the value is you will get the value as, sorry, this is 25 or 20. Maximum value is to be taken. This is 25. I'm so sorry. 15 plus 5 is 25. 25 comma 20. So maximum value is 25. Please remember this, maximum value is to be taken. So option A is the correct answer. Option A is the correct answer. Understood everyone? Yes. So the answer will be 25. Yes or no? Understood everyone? So the maximum value of among these two values. So from here you will get 25 and from here you will get 20. So the correct answer will be 25. Please remember this, the maximum value is to be taken. Yes or no? Now moving ahead. Solve this question. Now this is a question of steel structure. Okay, this is a question of steel structure. Put a star mark on this. Generally in a column base, the shear resistance at the proper contact surface between the steel base and the concrete may be calculated using the friction coefficient of, how much friction coefficient do you consider? You consider the friction coefficient of 0.45. You consider the friction coefficient of 0.45. Please put a star mark on this. So let us suppose so there is a steel base, then we have the column, and below the steel base there is a concrete. So there is a friction between the steel base and the concrete. How much friction coefficient do you consider? 0.45. Understood? 0.45. Now next question. Answer this. The minimum area of steel in mm square to be provided in a column of size 250 into 600. So the dimension is given as 250 into 600 mm. Okay, this is the column. So if I draw this, this will be like this. Okay, this is 600 and this is 250. So for this cross section area, minimum area of steel, what is the minimum area of steel? This is the column. What is the minimum area of steel? Can you answer me? Yes, just now we have seen the minimum area of steel is 0.8% of gross cross section area. 0.8% of gross cross section area is 250 into 600. 250 into 600. Yes or no? So from here you can see very carefully that two zeros are being cancelled out. Okay, and you can see 250 into 4 times is 250 into 4 times is 100. Okay, 100 and 150 into 0.8. So you'll get the answer as, you solve this question. So your answer will be 1200 mm. 1200 mm square. So this much is the area of the steel that is to be provided in the column section. Understood everyone? Clear? Yes, moving ahead. Moving ahead, solve this question. According to IS 456, okay, minimum slenderness ratio for a short concrete column. Please remember, you are asked with the short concrete. So pedestal, short concrete and long concrete. Slenderness ratio less than 3, pedestal 3 to 12, short column. More than 12, it is long column. Yes or no? So what will be the correct answer? What will be the correct answer? So your correct answer will be less than 12. Okay, less than 12. So all the values are more than 12. Hence the correct answer will be slenderness ratio less than 3, less than equal to 3. It is pedestal. And slenderness ratio greater than 3 but less than 12. Okay, it is short column. Slenderness ratio greater than 12, long column. Moving ahead. Yes, A is the correct answer. Answer this question. And just give me 1 minute guys. I need to fill my water bottle. Just give me 1 minute. What is the correct answer for this? Yes, look, the diameter of lateral ties in a column is taken as that diameter of lateral ties 1/4 of the diameter of the largest longitudinal bar 6 mm. So greater of 1/4 times the diameter of the largest longitudinal bar or 6 mm. So here the correct answer is option C. Here the correct answer is option C. Look very carefully. This is a very important question. Please put a star mark on this, each and every student. Okay, so the diameter of lateral ties, shall not be less than 6 mm or 1/4 times of the diameter of main bar. Okay, largest longitudinal bar or 6 mm. Understood everyone? Moving ahead. So moving ahead, next question. So I have tried to cover all the aspect of the column so that you will get each and every question from these question only. The minimum thickness of the RCC footing resting on soil is given by. So this is also very important question. Whenever the RCC footing is resting on the soil, what is the minimum thickness? Also comment me, whenever the footing is resting on the piles, then what is the minimum thickness of the footing? Answer me. What is the correct answer? Very, very good. Very good. Now look very carefully. Whenever the footing is resting on the soil, look, whenever the footing is resting on the soil, so the minimum edge thickness should be equal to 150 mm. And whenever footing is resting on the pile, okay, whenever the footing is resting on the piles, minimum edge thickness is 300 mm. So this you need to remember, 300 mm. Here the footing is resting on the soil, hence option A is the correct answer. Now moving ahead with the next question. Answer me guys. Answer me this question. What will be the correct answer? Very, very important question. The correct, very, very good. The minimum clear cover in RCC column. So the clear cover, now this we are talking about RCC column and clear cover. Clear cover is nothing but greater of 40 mm, either 40 mm or diameter of reinforcement, understood? Or diameter of reinforcement, whichever is greater. Okay, whichever is greater. So maximum of two values is this. So this is the clear cover, greater of 40 mm or diameter of reinforcement, hence option A is the correct answer. Understood everyone? Option A is the correct answer. Yes, very, very good. So the next question is this. Answer this. A helically reinforced column of 300 mm diameter has 6 bars of 24 mm diameter, has longitudinal reinforcement provided an effective cover of 60 mm and spiral of 8 mm. Diameter provided at clear cover of 40 mm. The core diameter of this column is, very, very important question. You are asked about the core diameter. Okay. Now what is given in the question? A helically reinforced column of 300 mm diameter. So the column diameter is nothing but this is given in the question. This diameter is 300 mm. this diameter is 300 mm. This is given in the question. Okay, has reinforced column of 300 diameter, has 6 bars of 24 mm diameter as longitudinal reinforcement, as an effective cover of 60 mm. Okay, so 6 bars are there. So 1 bar, 2 bar, 3 bar, 4 bar, as well as 5 bar and 6 bar. So 6 bars are there. Okay, clear cover of 60 mm, spiral of 8 mm. Okay, and spiral of 8 mm is also provided. So this diameter is 8 mm. This diameter is 8 mm. This diameter is 8 mm. Understood everyone? Spiral diameter is 8 mm. As well as the 6, 1, 2, 3, 4, 5, 6. So 6 bars are there. Okay, 24 mm diameter. So these bars are of 24 mm diameter. These are the main bars. Okay. Spiral of 8 mm. Diameter provided at clear cover of 40 mm. Clear cover of 40 mm. The core diameter of the column is. Please answer this. You are asked to find the core diameter. How will you solve the question? You can see very carefully. This is 300 mm and you can see the clear cover is of 40 mm. So clear cover, you are asked to find this length. Please look very carefully. You are asked to find this length. This is the core diameter. Now you can see total length is 300. Total length is 300 and a clear cover of 40 mm is there. This is also 40 mm. This is also 40 mm. So you can see very carefully. This is 40 mm and this is also 40 mm. So in 300 mm, if you subtract 2 times of 40 mm, you will get the answer as 80, 220. The core diameter is 220 mm. Option B is the correct answer. Understood everyone? Yes or no? Are you getting my point? Yes or no? So clear cover is 40 mm. So diameter of the core is nothing but 300 minus 80, that is 220. Now moving ahead. Answer this question. In reinforced concrete, pedestal is defined as compression member whose effective length does not exceed its lead. So slenderness ratio is less than 3, is less than equal to 3. Okay. So least lateral slenderness effective length upon least lateral dimension. Least lateral dimension. It should be less than 3. So you can see very carefully. Pedestal defined as a compression member whose effective length does not exceed. So does not exceed 3 times of the least lateral dimension. Hence the correct answer is option B is the correct answer. I hope it is clear. Yes or no? Okay, moving ahead. Moving ahead with the next question. Answer this. Answer this question. The critical section for computing maximum bending moment for the design of isolated footing. So you can see very carefully. I will show you the isolated footing. This is an isolated footing. Okay. So and the top view is looks like this. Top view is look like something like this. Something like this. So this is the top view and this is the cross section. This is cross section view and this is top view. Okay. The critical section for computing maximum bending moment for the design of isolated footing supporting a concrete column is consider D as the distance between the column face and the footing edge. So you can see very carefully this distance is nothing but D. This distance is D. So now at the face of the, now for critical section for bending moment, yes, very good. So the face of the column is considered at, so at this point, we get the maximum bending moment. So at the face of the column we get the maximum bending moment. Option A is the correct answer. This is not the check for two-way or one-way shear. This is the bending moment. So we'll get the maximum bending moment at the face of the column. Option A is the correct answer. Yes or no? Understood everyone? Now moving ahead with the next question. Answer this question everyone. What is the minimum number of longitudinal bar provided in reinforced concrete column of circular cross section? Please answer if the cross section is square or rectangle, and if the cross section is circular. Okay, so minimum number of reinforcement. What is the minimum number of reinforcement? Minimum number of reinforcement. For square or rectangular column it is 4, and for circular column it is 6. Okay, 6 number of reinforcement bar is provided when the column cross section is circular. Understood everyone? 6 is the correct answer. Now moving ahead. Yes, for one-way shear, D from the face of the column. For two-way shear, D by 2 from the face of the column. Very, very good, Vignesh. Okay, very, very good. So, but in the previous question, it was asked about the bending moment. Okay, so that is why face of the column is the correct answer. Now moving ahead, answer this question. Answer this question. The pitch of lateral ties in RCC column should not exceed. Pitch of lateral ties. Pitch of lateral ties. In RCC column should not exceed. Answer this question. Pitch of lateral ties in RCC column should not exceed the least lateral dimension. Okay, least lateral dimension 16 times of the diameter of main bars. Okay, main longitudinal bars, or 300 mm. Okay, should not exceed least lateral dimension. Just now we have seen the question. So pitch of the lateral ties should not be more than of all the values. So all the above. Option D is the correct answer. Understood everyone? Moving ahead, next question. Answer this question. In the case of column of minimum dimension of 200 mm or under, whose reinforcing bar does not exceed 12 mm, a nominal cover may be provided. So very important question. How much is the nominal cover that you provide in this case when the diameter is not more than 12 mm? So again a very good question. Now very, very good, Vignesh, very, very good. So whenever you see that in case of column of minimum dimension of 200, whenever the dimension of column is 200 mm or under, okay, and when you are using the diameter of the bar as 12 mm, you can see the clear cover here in this case is not 40 mm. The clear cover here in this case is 25 mm. Clear cover in this case here is 25 mm. Hence option B is the correct answer. Option B is the correct answer. Understood everyone? Now moving ahead. Answer this question. Answer this question. A square column of section. So it is a square column, 350 mm size, 350 mm into 350 mm. Okay, 350 mm into 350 mm. So this is also a very good question. Okay, very good question. Okay, is 4 bars of 25. So the main bars is of 25 mm diameter. 25 mm diameter. 4 bars of 25 mm diameter and 4 bars of 16 mm diameter. So the the transverse reinforcement. So you can see very carefully the transverse reinforcement. Okay, the dia of transverse reinforcement shall not be less than 1/4 times of the main reinforcement as well as 6 mm. 6 mm. So what will be the correct answer? 1/4 times of the minimum of these two is nothing but 25, okay, or 6 mm, and the spacing is nothing but least lateral dimension 16 times of the dia of the main bars as well as 300 mm. So you want, now in order to remember this, you want the diameter to be maximum but you want the spacing to be minimum. So 16 times of the diameter of the main bar. So main bars is of 16 mm as well as 25 mm. So least lateral dimension is 350. Here it is 300. Okay, you want spacing to be minimum. So if you want minimum, so here you take the minimum of this value, that is 16 into 16. Yes or no? And you want diameter to be maximum. So 25/4 or 6 mm. So you will get the answer. Maximum of this bar. So 25/4 is nothing but, so here you can see 7. So here you can see it is more than 6. It is more than 6. So you'll select the option which is more than 6. So only one option is there, this one and this one. So here the spacing will be minimum of this value. So 300 mm is the correct answer. Option B is the correct answer. Option B is the correct answer. 8 mm and 300 mm. Okay, 8 mm and 300 mm. Clear everyone? Clear? So 300 mm and 8 mm is the correct answer. Moving ahead. As per IS 456-2000, the minimum nominal cover specified for the footing is. So the footing for nominal cover for footing. Answer this question. Nominal cover for footing is. Answer this question. So what is the nominal cover specified for footing? So for footing it is 50 mm. Very, very good. So for nominal cover for footing, so you can see very carefully, nominal cover for footing. Nominal cover for footing. It is nothing but 50 mm. So you'll get the answer as 50 mm. Option C is the correct answer. Understood everyone? Okay, moving ahead. Please answer this question. For a square reinforced concrete RC column with cross section of 300 into 300 mm having an effective length of 2500 mm, determine the minimum eccentricity. So minimum eccentricity, just now we have seen L upon 500 plus least lateral dimension upon 30 or 20 mm, whichever is minimum. So the length is nothing but 2500 divided by 500, that is 5, plus least lateral dimension is nothing but 300 mm divided by 30. So you can see very carefully, this is 5 and this is 30. So this is 35 and minimum of 20. So the minimum eccentricity is 35, 20. So answer me, what will be the correct answer? What will be the correct answer? So greater value is taken. Just a moment. So this is 5. Okay, this is 10. I'm so sorry. This is 10. 15, 20. 15, 20. So greater value is taken. Maximum value is taken. Hence the correct option will be 20 mm. Option C is the correct answer. Yes, for flat slab is it? Yes, very, very good. Yes, Vignesh. For normal slab it is 20 mm. Understood? So here we'll get the value as minimum eccentricity as, okay, minimum eccentricity as 20 mm. So maximum value is to be taken. Moving ahead. Answer this question. Answer this question. This is a question of footing. Answer this. Determine the plan area of the footing carrying a load of, so on the column, the footing, the load is coming out to be 1500 kilonewton. 1500 kilonewton from 300 mm square column. So here the column size is 300 mm square column, okay, containing 20 mm diameter bar. So the bars contain 20 mm diameter bar. Yes or no? Longitudinal C, the safe bearing capacity of the soil is. So you can see very carefully, okay, 120 kilonewton per meter square, 1 meter square area resist. So for 120 kilonewton, you need the footing of area 1 meter square, okay. So for 1 kilonewton, you need the area as 1 upon 120. For 1500 kilonewton, you need the area to be 1500 divided by 120. So you'll get the answer as 150 divided by 12. That is equal to, okay, 4 divided by 50. So that is 5. If it is 50 divided by 4, 50 divided by 4 means 25 by 2. 12.5 meter square is the correct answer. 12.5 meter square is the correct answer. Yes or no? Please look, by just unitary method we have solved this question. Just by applying the unitary method we will be able to solve this question. Yes or no? Understood everyone? Okay, moving ahead. Next question. Answer this question. Answer this. Determine the minimum and maximum longitudinal reinforcement. Minimum and maximum longitudinal reinforcement for a square column of size 300 into 300 mm having clear cover of 20 mm. So you can see the minimum reinforcement, the minimum area of reinforcement is nothing but, minimum area of reinforcement is calculated as, minimum area is nothing but 0.8% of the gross cross section area. So gross cross section area is 300 into 300 mm. Yes or no? So this is nothing but 900. So this is 720 mm square. So you have eliminated option A and B, and the maximum reinforcement is, it is nothing but, this is 0.8%, 6% of gross cross section area. Yes or no? So this is nothing but 5400 mm square. 5400 mm square is option D. So this is nothing but 5400 mm square. So this is the maximum area and this is the minimum area. Clear everyone? Understood? Shall I move ahead? Moving ahead. Answer. The purpose of lateral ties in a short RC column is to. Now please remember, in this question you are asked with lateral ties as well as for short column. Okay. So what are the purpose of lateral ties in short reinforced concrete column? Option is avoid buckling of longitudinal bar, facilitate construction, facilitate compaction of concrete, increase the load carrying capacity of the column. So very good question. So why we use the lateral ties? In the question also it is given ties. So ties means something which can bind. So I'll show you the diagram. You can see very carefully. And you can see these are the longitudinal bar and these are the lateral ties. You can see these are the lateral ties. Yes or no? So the main bar does not buckle. So the lateral ties holds the buckling of the main longitudinal bar. Hence option avoid buckling of the longitudinal bar. Option A is the correct answer. No. The main purpose of longitudinal ties is not to take the load. It does not design to take the load, but rather it is designed such that the buckling of the longitudinal bars are prevented. So this is the main reason. Please put a star mark on this. Arun Kumar, yes, this is the correct answer. Option A is the correct answer. Understood everyone? Clear? Please put a star mark on this. Understood? Shall I move ahead? Now next question. So next question is this. Okay, this is also a good question. You need to apply the formula in order to solve this question. Please apply the formula for question number 27. Okay, you are confused about this. Okay, just a moment. Now you can see whether it is a short column or long column. If it is a short column also, you can see very carefully. Now your doubt is very good, but sir, it is given a short column. Okay, short column. Even though it is a short column, the purpose of lateral ties is to hold the main bars in position. Understood everyone? Understood? Loss due to relaxation. Now you can see very carefully. हम स्टील को क्या करते हैं? स्ट्रेस करते हैं. हम स्टील को स्ट्रेस करते हैं, टॉर्जन देते हैं. ठीक है, हम जब स्टील को स्ट्रेस देते हैं, अब देखो ना स्टील का द स्ट्रेस स्ट्रेन डायग्राम फॉर स्टील इज दिस. सो एट यील्ड प्लेट्यू देयर इज अ लार्ज स्ट्रेन. In order to avoid this large strain, we stress the steel and then we release the load. So whenever we release the load, this much is the plastic strain is induced in the steel, and some stresses are also induced in the steel. Over the period of time, this stress releases. So that is known as relaxation. Understood? Even though it is a short column, Vignesh, even though it is a short column, the main purpose of lateral ties is not to increase the load, but rather it is there to hold the position of the main bars. Understood? Because a column is a compression member. Okay, column is a compression member. So they do not displace from their own position. That is why they are given. Now moving ahead. Answer this question. I'll give you the hint. I'll give you the formula for this. Then you apply the equation. Answer this. So what is the depth of the footing as per Rankine formula? Depth of footing as per Rankine formula. Depth of footing as per Rankine formula. So depth is given as P upon gamma 1 minus sin phi upon 1 plus sin phi. Friction angle is this. So this is the depth of the footing. Okay, 230 mm brick masonry wall is to be provided with reinforced concrete footing on site, having soil with safe bearing capacity of 125 kilonewton per meter square, unit weight of 17.5 kilonewton per meter square, and angle of shearing resistance is 30 degree. Depth of footing. Okay, depth of footing. So you can see very carefully friction angle is given. So 1 minus sin 30 degree upon 1 plus sine 30 degree. So you can see 30 degree is very simple, sine of 30 degree is very simple. What is P upon Y? This safe bearing capacity as well as unit weight. So you can see very carefully the question, in the question it is given as safe bearing capacity is 125 kilonewton per meter square, and what is the unit weight? Unit weight is nothing but 17.5. So dimension wise this will comes out to be in meter. Okay, so you can see 125. What is sine 30? Half. 1 minus half is 0.5. 0.5 upon 17.5. 17.5 into half, sine 30 is half. So 1.5. 1.5. Yes or no? Clear everyone? So what will be the correct answer? So square of this is also there. Yeah, I'm so sorry. Square. So you can see 0.5 upon 1.5 square. So you solve the answer, you'll get the answer in meter. So on solving, you'll get the values as 0.8 meter. So minimum of 0.8 meter depth is required in this case. Yes, Q upon gamma. Yes, instead of Q, I have taken P. That signifies the safe bearing capacity. Understood? Moving ahead. Answer this question. Answer this question. Now, you can use the virtual calculator for this question. You are allowed to use virtual calculator in this case. Shall I solve the question? Now look, a circular column is subjected to unfactored load of 1600 kilonewton. So a circular column, so what is the unfactored load of 1600 kilonewton? Okay, so this is given in the question. As well as the effective length of the column is, 3.5 meter. The concrete is M25 and area of steel is nothing but area of steel in ASC, and the value of this ratio ASC upon AG is equals to 2%. Okay, what is the area of steel in concrete? That is 2% of gross area. So what is the area of concrete? That is 98% of gross area. 98% of gross area, which is given in the question for Fe415 steel. Okay, design diameter of the column will be, so load is given. We know the formula. Design load, design diameter of the column. So what is the formula for load? So unfactored load is given as 1600 kilo. So what is the factored load? Factored load is 1.5 into 1600. Okay, so what is the formula? PU is equals to, what is the load carrying capacity of column? PU is nothing but, we get the formula as 0.4 times of 40% of FCK into area of concrete plus 0.67 Fy into area of steel in compression. Yes or no? Fy into area of compression. So from here you will get the value as 60%. 50% if you increases, it will be 2400 kilonewton is equals to 0.4 into FCK. FCK is given as M25. What is the area of concrete? Area of concrete is 98% of gross area plus what is 0.67, yield stress is nothing but 415 into, that is 2% of gross area. Yes or no? 2% of gross area. So this is the equation of gross area. What is gross area? Pi by 4 into d square. So in order to convert this in kilonewton, you convert this in Newton. Okay, convert this in Newton, 2400. So the equation will look like this. This equation will look like this: 2400 into 10 power 3 is equal to 0.4 into FCK is nothing but FCK value is M25 into 0.98 into pi by 4 into capital D square plus 0.67 into 415 into 0.02 into pi by 4 into capital D square. So this is the equation in D. You will get the value D in mm. You will get the value D in mm. So whenever you solve the question, it will be 446. You solve the question, you will get the value as 446. Just try to solve this equation. No, Vignesh, this is clear. So you solve the equation, you just by virtual calculator you need to solve the equation. So these questions are deliberately given, okay, so that you can consume time. Shall we move ahead? Have you understood the concept? Apart from calculation part, have you understood the concept? Yes or no? Have you understood the concept? Yes or no? Please tell me. Shall I move ahead? Okay, moving ahead. Similar question, a kind of similar question, but only twist is here. Look very carefully. The ultimate load carrying capacity of a short circular column of 300 mm diameter with 1% helical reinforcement of Fe415 grade steel and concrete M20 grade is nearly Fe415. Please change it to Fe415. A kind of similar question. So whenever helical reinforcements are given, load carrying capacity increases by 5%. So whenever you need to increase something by 5%, 1.05, 40% of FCK into area of concrete, okay, plus 0.67 Fy into area of steel in compression. So this is the formula that you need to apply. Answer me, guys. So you can use the virtual calculator. The ultimate load carrying capacity of short circular column 300 mm diameter. So what is the gross area? Gross area is nothing but pi by 4 into 300 square with 1% of helical. Now what is the reinforcement? Reinforcement here is nothing but 1%. So how about the area of concrete? That is 99%. Yes or no? That is 99%. So you can see area of concrete is nothing but 99% of gross cross section area. 99% of pi by 4 into 300 square. And what is the area of steel? Area of steel is nothing but 1% of pi by 4 into 300 square. Okay, so this is given in the question. So you can solve. The equation will comes out to be what is the load carrying capacity PU. PU is nothing but 1.05. So here 0.40 into FCK. What is the grade of the concrete? That is 20 into area of steel, area of concrete, that is 99. 0.99 of pi by 4 into 300 square. Okay, as well as plus 0.67. What is the area of steel? That is 4. What is the grade of the steel? 0.415 into that is the area of the steel in area of steel in compression is nothing but 0.01 into pi by 4 into 300 square. You convert this in kilonewton multiplied by 10 power minus 3. So from here you will get the answer as 794 kilonewton. 794 kilonewton. Okay, this is the equation that you need to solve. 794 is option D. Okay, deliberately this is given. Why? Because you will commit the mistake, you will consume the time. You will not commit the mistake because it is a simple calculation, but by the help of virtual calculator, it takes a lot of time to solve these questions. So these questions are to be solved at the last, whenever you complete the paper. So these questions are to be solved at the last by the help of virtual calculator. Understood everyone? Understood? So a similar question, again I'll give you a similar question. So two concepts I have given. Okay, in one of the question no helical reinforcement, in second question there is a helical reinforcement, in the third question there is a concentric load. So apply the concept, apply the concept. Apply the concept. Again this is a very good question. Okay, I'll solve the question, don't worry. Now in this question, a certain RC short column with 300 mm square cross section is made of, so this is a square cross section 300 mm 300 mm, okay, square cross section, grade of concrete is M20. So what is the area of steel? Area of steel is 415, so grade is Fe 415. What is area of steel in compression? That is 4 bars of 20 mm diameter. Yes or no? Concentric. This is a concentric axial compression load. Please remember concentric axial load, ignoring the reduction in the area of concrete due to steel bar. So in the question, what is the area of concrete? Because there is no reduction, the gross area is nothing but the area of concrete. What is the gross area? Gross area is nothing but 300 into 300. 300 into 300. So this is given in the question. As per the question, we are solving the question. Okay. The ultimate load carrying capacity of the column by the relevant code is. So you can see what is the load carrying capacity here. You can see the answer will be nothing but. So it is a concentric load. So this is nothing but 0.45 FCK into area of concrete plus 0.65. So 0.45 into 0.75 into Fi into area of steel. So you can see the 0.45, what is the grade of concrete? Grade of concrete is 20. What is the area of concrete? Area of concrete is given as 300 into 300. 300 into 300 plus 0.75 into, what is the grade of the steel? That is 415. What is the area of steel? 4 times of pi by 4. What is the diameter? 20. So in order to convert this in kilonewton, multiplied by 10 power minus 3. So you'll get the answer in kilonewton. So this is just the equation. So whenever you solve this question, the answer is 1201 kilonewton. Option B is the correct answer. Have you understood the concept? Yes or no? Is it clear? I hope it is clear. Yes or no? Now, look, as per IS code, why we have changed the formula in the previous question. Whenever we design the load carrying capacity of the column, we consider the column designed to be minimum eccentricity. But here we are designing the column with no eccentricity, the concentric axial compression. So whenever there is a concentric load in the column, the load carrying capacity, the formula is this one. Understood, Vignesh? And if nothing is given in the equation, we always consider the load carrying capacity or the column to be minimum eccentricity. That is why we have applied this formula. Good afternoon, Sachin. Understood? Yes or no? Please remember this point. Okay. Okay, we will take last 10 question for column and footing. Then this chapter will be finished. Okay, moving ahead. Apply the logic. What is the correct answer? What is the correct answer? The correct answer for this question is yes, very good. In an isolated reinforced concrete footing of effective depth D, you can see very carefully. Look, this is the footing. This is the footing of effective depth D. Okay, the stress in punching shear is checked. So what is punching shear? Yes, very good. So it is a two-way shear. Okay, it is a two-way shear, punching shear. So okay, so whenever you can see, this is the plan, this is the plan. So punching shear means the column will punch into the footing. Okay, so this is the cross section. So at all the faces, from all the faces at D by 2, from all the faces of D by 2, we will check for punching shear. So at this cross section, the punching shear is maximum at a distance D by 2 away from the face of the column. Okay, from the face of the column, please understood, from the face of the column. As you can see, I have shown you the in diagram also from the face of the column. Okay, moving ahead. Correct answer is, what is the correct answer for this question? Yes, that is a two-way shear. Very good. So what is the correct answer? Again, this is a very simple question. The effective length of circular electric pole of length L and constant diameter erected on ground. So this is a electric pole of circular diameter and erected on the ground. The effective length of circular electric pole of length L and constant diameter. So this is length L and the diameter is D. Okay, erected on the ground. So what is the effective length? You can see very carefully. So one end is free, another end is fixed. So the correct answer will be effective length is nothing but 2 times of the length. 2 times of the length. Understood, everyone? So the correct answer will be D. Yes or no? This is very simple question. Next question. Answer this question. Answer this question and put a star mark on this. I'll find this question very important for your upcoming examination. Okay, a reduction factor CR to the load carrying capacity of long column. So whenever there is a long column fails by buckling. So what is the reduction factor? What is the reduction factor that we apply? 1.25 minus LE upon 24B. Effective length is LE. 1 minus LE upon 48B. 1.25 minus LE upon 48B. So this is just by observation. LE upon 48B is the correct. Okay. How about 1.25 and 1.5? So what is the correct answer for this? Answer me. Yes, very good. So from here from the logic you can apply that in most of the equation, in most of the option, LE by 48B is there. So LE upon 24B will not be there. Whenever you look at this side, so in most of the option you will see 1.25. So most probably, so from the random guess you can say that the correct answer is option C. So the reduction formula is nothing but 1.25 minus LE upon 48B. Just so every time this does not hold good, but here just by observation, if you want to take the hit and try, okay, then you can see the options are framed in such a way that LE upon 48B is on the maximum option. So most probably LE upon 48B, but on the left hand side you can see 1/25 is on in major on in maximum option. So most probably your option will be 1.25 minus LE upon 48B. It is just a random guess to tick the options. Understood? Shall I move ahead? Okay, this is the least lateral dimension. This is least lateral. This B is nothing but least lateral dimension. Okay. Answer me. This formula we have applied in this today's class only. This formula we have applied in today's class only. What will be the correct answer? So W is the weight per unit volume, P is the safe bearing capacity, and phi is the angle of repose, okay, of the soil retained by the retaining wall. The minimum depth of the foundation to be calculated as, so minimum depth of the formula is given by the Rankine formula. This is given by Rankine formula. So as per Rankine formula, what is the depth? So that is Q or P, whatever you want to state, that is P upon W. Okay, P is nothing but W is nothing but gamma. Gamma is nothing but unit weight of the soil. Gamma is nothing but the unit weight of the soil as it is given in the question. W is the weight per unit volume, or here W is weight per unit volume, 1 minus sin phi upon 1 plus sin phi square. So what is the correct option? Option A is the correct answer. This we have solved the question also on this. Yes or no? Now moving ahead. Next question. Again, it is a very simple question and last 5 question for this chapter. Recommended value of effective length L0 of a long RCC column, okay, as compared to the actual length L, effectively held in position and restrained against rotation at both the end. So whenever the column is effectively held in position and restrained against rotation, it means both the end is fixed. So in both the end is fixed by on applying the load. Whenever the load is applied, this is the bending criteria. So you can see distance between the point of zero bending moment is this much. Yes or no? So 50% of the L, but as per IS code, 50% of the L, but as per IS, the theoretical value is, theoretical length is nothing but 50% of the length, but as per IS code, we take this value as 0.65 times of the L. Yes or no? 0.65 times of the L. Option D is the correct answer. The code states that there is no 100% fixity at the support. Okay, that is why some more length will also get deflected. Hence, we'll take the greater length, 65% of the length. Yes or no? Now moving ahead. Next question. Answer this question, everyone. As per IS 45, the minimum cover to be for column. Just now we have seen for column and for footing. What is the minimum cover? What is the minimum cover? So 2 cover we have seen. If the diameter is 12 mm and if the diameter is more than 12 mm. So what is the cover? Minimum cover for column. Minimum cover to column is nothing but 40 mm. So this is given as 40 mm. Yes or no? So your answer will be option B. B is the correct answer. Yes or no, guys? Okay. B for Bahubali. Yes, B for Bahubali is the correct answer. Okay. But if the diameter is of 12 mm, then we would have been chosen 25 mm. Okay. Yes. Now less than 12 means, now Sachin, the minimum diameter to be used in column is 12 mm. So it means that 25 mm is applicable only for 12 mm diameter. Okay. Now moving ahead. Answer this question. An RCC column of 4 meter length is rigidly connected to the slab and to the foundation. Its cross section is, it is a square column of 400 into 400 mm. Okay, it is a square column of 400 into the column will be behave as long column, short column. So you find out the slenderness ratio. Slenderness ratio is effective length upon least lateral dimension. Least lateral dimension. So you can see here both the dimension are for 400 mm. So what is the effective length? So column length is 400, that is 4 meter. 4 meter means 4000 mm upon 400. So this value is 10. So you can see very carefully, this value is more than 3, this value is more than 3 and less than 12. This value is more than 3, lambda is more than 3 but less than 12. Yes or no? So it is a short column or long column? It is a short column or long column? Answer me, guys. So it is a short column. Understood, everyone? Yes or no? If this value comes out to be less than 3, it is a pedestal. If its value is greater than 12, it is a long column. Okay. Moving ahead. So last 3 questions. Answer this. If in any given plane, one end of the column is unrestrained and its supported length L shall not exceed. Okay, so again consider this as to be a cantilever beam. If in any given plane, one end of the column is unrestrained and its unsupported length is L, shall not exceed. Unsupported length shall not exceed. So what will be the correct answer? In order to prevent from buckling, the unsupported length shall not be less than, very good, 100 b square by d. It should not exceed 100 b square by d. Yes, option B is the correct answer. Understood, everyone? Moving ahead. Again, this is a very good question. Reduction factor for RC column. Now you can see effective length to least lateral dimension is given as 24. It is a long column. So for long column, you know that what is the reduction factor? Just now we have seen CR is nothing but 1.25 minus effective length upon 48 times of the least lateral dimension. Yes or no? L effective upon 48 times of the least lateral dimension. So you can see this is given as, what will be the correct answer? No need to solve the question. 1.25 minus effective length upon B is given as 24. So 24 divided by 48. So it is nothing but this value is 0.5. So in 1.25 subtract 0.5. So you'll get the answer. Very good question. Okay. The data are given in such a way that without calculator you will be able to solve the question. Yes or no? Yes or no, everyone? So the correct answer is here is option D. Option D is the correct answer. So last question for today's class. Okay. Last question for today's class is this. So what is the critical section for bending? What is the critical section for bending in footing should be considered? So in footing, you can see very carefully, this is the footing. Okay, the depth is D. Okay, this is the face of the column, and if I draw the plan, it look like this. Very good. So for bending, yes, for bending, this section have the maximum bending at the face of the column. So this section at the face of the column, at this section we get the maximum bending moments. Hence the option C is the correct answer. Understood, everyone? So this is it, guys. This is it for today's class. I hope you have enjoyed the question for column and footing. I have tried to cover each and every aspect of this chapter. Okay. Vignesh, physics and chemistry. Okay, I'll try to take physics and chemistry. My team is working on making the PPTs for physics and chemistry. I mean, I'm not pretty sure that I'll be able to complete this before RRB JE, but yes, we are working on it. So that because physics and chemistry and biology are considered in examinations like RRB JE and SSC JE. Okay, I'm not pretty sure, but yes, I will try to take physics and chemistry. I'll give my 100% to cover the PPTs, to make the PPTs, because we are making the animated PPTs. Okay, so it takes a lot of time for me as well as for my team also to work on it. I hope this is clear. We have taken very good questions of RCC. Trust me guys, it takes me around 1.5 months to frame such questions. So I have taken from reference from so many books. Then I'll be able to make such questions. Understood? And you can see smartly we have covered all the concepts of RCC for beam, slab, column, and as well as design consideration. Clear everyone? So this is it from my side. Okay. So so few days are left for your RRB JE examination. I'll suggest you to be patient and be calm. Okay. So most of the student gets, in the last moment, most of the student get confused. So you need to be very clear about your mission as well as clear about your planning. So in last few days, what you have to revise and how much time you have to devote for your revision for different subjects. So this is how make a clear plan for last moment, and please don't get panic in the last moment. Understood everyone? So thank you so much guys for joining in this session. If it is possible for you to please share these sessions among your friends so that they also get benefited. And all the lectures of these RCC sessions are in English. So South Indian student also get benefited from it. Please share it to your juniors so that they can get the quality questions of RCC. Thank you so much guys for joining. Thank you so much. Bye bye everyone, and good luck for your examination.